This is Forces Podcast 5, and this is about pressure. So pressure is exerted when a force is applied over a certain area. So you can see the child here, she's got her finger pressing down on a surface and then she's putting her hand onto the surface. And the question says beneath, if the same force is applied in each picture, which arm exerts the highest pressure on the board or on the surface? So she's got her weight on over a wide area and she's got her weight on here over a very small area. So if we have a look at the question, we should be able to answer, or the equation, we should be able to answer that question. So to calculate pressure, pressure is calculated using force over area. So pressure is measured in, now we can use newtons per metre squared. So newtons per metre squared, and the other name we give that is pascals. And we shorten that to a PA. Now there is a second unit that we can use, and it's newtons per centimetre squared. Depends on what your area is measured in. But if you write newtons per centimetre squared, 1 newton per centimetre squared is not equal to 1 pascal. So I'm just going to write that in. 1 newton per centimetre squared is not equal to a pascal. So just be careful about that. It is an acceptable unit, but it isn't the same as a pascal. So if I go back to this picture of the child again, you can see there that she's applying the same force in each case, but this is over a small area and this one is over a large area. So if you divide by a small number, you get a big answer, and if you divide by a big number, you get a small answer. And so the answer is that the child with her finger pressing down onto the surface is actually applying the highest pressure. Right, this is another diagram which demonstrates high and low pressure. Remember, pressure is force over area. If I just write that up here. So if these two people weighed the same, but they're wearing two different shoes. So this lady is wearing a pair of boots here, and they have got quite a wide area, a nice big round heel and a round sole. And then she appears a second time in a different pair of shoes with a small area, fairly small sole and quite a narrow heel. Then in each case, she's applying a pressure of the same force, but there's a large area here and a small area here. And therefore she's applying a larger pressure here. Now it used to be in the old days that in dance floors or in dance halls where they had lovely wooden floors, there would be notices up all over the place, no stiletto heels. And the reason is stiletto heels are, of course, if I just draw a foot there, not a very good foot, but there's a stiletto heel there. Very pointy sole there, or very pointy heel, and that heel just dug straight into the floor and left marks on the floor. So that was the reason why halls with lovely wooden floors would have said no stiletto heels, because a stiletto heel applied an awful lot of pressure on the floor. Right, using low pressure, this is someone on a snowboard, and they're applying a low pressure because their weight is spread over a large area, the area of the board. So that's a low pressure that they're applying. Now you may have seen a picture of maybe snowshoes that maybe people would wear, and a snowshoe is not unlike a tennis racket kind of idea, where you strap these, or it used to be, you strap these things to your feet and they were strung like tennis rackets. But what happened was whenever you put your foot on that, then that spread your weight over a much larger area, and therefore that meant you had a lower pressure. High pressure. There's lots of situations where we want a high pressure. When we're chopping food, for example, if you have a force, which is the force of your hand pressing down, concentrated on a small area. So if you have a very sharp knife, you have a very small area on the blade, and that means that you get a high pressure using a small force. So pressure is force over area. The smaller the area you use, the larger the pressure you get. And that's why chefs will always sharpen their knives before they start cutting meat and so on, because it is actually less dangerous for them to use a sharp knife because they're actually using less force, and there's less danger of the knife slipping and cutting them. This is another place where you would have a high pressure. This is a tack. I tried to get a picture on the internet of a conventional tack, which is a round end like that and a pointy surface. You put your thumb on this part. I couldn't get one, but this is the other type of tack, which is a little bit harder to put into a notice board. So it's got a pointy surface here, and that gives you a very high pressure here, and that means it's easy for you to be able to push the tack into a notice board using a high pressure and not too much force. But the other end of it there has got quite a large area. In particular, this one here has got a very large area, and that means that when you put your thumb on that surface isn't a pointy surface which is going to dig in and hurt your thumb. It's not going to hurt you like that there. And so that's the reason why one end of the tack has got a nice big round area. It's got a low pressure whenever you put your thumb on it. It exerts a low pressure on your thumb. But the other end's pointed, it exerts a high pressure on the notice board. Now,